Hello my dear students, good evening to all of you. Today I am going to teach you a new chapter which is called as vector. In this chapter, first of all I will discuss about physical quantities and then after I will discuss about types of physical quantities. In some books, physical quantities are divided mainly into two parts. First one is vector quantity and second one is a scalar quantity. But in some books, physical quantities are divided into three parts. First one is vector quantity, second one is a scalar quantity, and third one is tensor quantities. So I will also divide the physical quantity into three parts. First one is vector quantity and second one is a scalar quantity and last one is tensor quantity. I will discuss one by one in detail. First of all, I am going to define physical quantities. What are the physical quantities? Those quantities which can be measured are called physical quantities, such as mass, length, time, volume, etc. Chapter name is vector, and in this chapter, first of all, I am going to discuss what are physical quantities. Physical quantities. Right? Those quantities which are measurable. You can also say, in other words, the quantities which can be measured are called physical quantities. The quantities which can be measured are called physical quantities. Are called physical quantities. Such as for example, mass can be measured in kg or gram etc. Similarly, distance can be measured in kilometer, mile, meter, etc. Time also can be measured in second, hour, minutes, etc. A speed also can be measured with the help of a speedometer connected in different types of vehicles such as bike, car, etc. In bike, you can see a speedometer which shows how fast, how slow, how slow vehicle is moving. Let us consider a biker is moving with 72 km per hour. This means that pointer of a speedometer points towards 72 kilometer per hour. Okay. So a speed can be measured in kilometer per hour, meter per second, etc. Now now I am going to take another example. Area. Area can be measured. You have already studied in previous classes about area of rectangle, area of a square, area of trapezium, etc. Area can be measured in meter square, centimeter square, etc. Similarly, volume can also be measured. How can you measure volume? If you go to a petrol pump with a bike or car to fill the petrol, in bike or car, (5 liters, 6 liters, 10 liters, etc.). These are volumes. Volume can be measured in liters, meter cube, centimeter cube, etc. Can you measure momentum? Yes. How can you measure momentum? Momentum can be measured in kg meter per second. Why? We know that formula of momentum is mass into velocity. Unit of mass is kg and unit of velocity is meter per second. Therefore, momentum can be measured in kg meter per second. Okay? Got it? etc. There are large number of physical quantities in physics. So, total number of physical quantities cannot be written here. Therefore, I put etc. Which quantities cannot be measurable? Such as beauty, smartness, sweetness, blackness, whiteness. These quantities are not measurable. You can only feel. As for example, I have a copy and board. Which is more bright? Which one is more bright? Which one is more white? Board is more white than copy. But how much? 3 kg, 2 kg, 5 meter per second? It is wrong. It cannot be measured exactly. You can only feel. You can only feel board is more white than copy, but you cannot measure exactly. Okay? Therefore, these quantities are non-physical quantities. Right? In physics, we have to study about physical quantities only, not about non-physical quantities, because physical quantities are those quantities which can be measured. Therefore, physics can be also defined as it is the science of measurement. Okay? So, non-physical quantities. So, in physics, we have not studied about non-physical quantities. Now I am going to classify. Now I am going to classify the physical quantities. Physical quantities are divided into three parts. First one is, first of all, I am going to give a question, and then after I will divide physical quantities. Okay? First of all, I am going to give a question on this theory. Question is, which of the following is are physical quantities? Can you give answer? First option is force. Second option is whiteness. Third option is beauty. And last one is area. Which is measurable quantities? Force is measurable, area is measurable. Those quantities which are measurable are called physical quantities. Okay? Now I am going to divide physical quantities into three parts. Physical quantities into three parts. First one is vector quantities. And second one is scalar quantities. And the last one is tensor quantities. I will discuss about each of these quantities in detail. First of all, I will discuss about vector quantities, and then after I will discuss about the scalar quantities. After that, I will discuss about tensor quantities. Now I am going to teach you about vector quantities. First of all, I will define vector quantities. Vector quantities. What are the vector quantities? The physical quantity are divided into three parts: first vector and second scalar and third tensor. The physical quantities which have magnitude as well as a specified direction and obey the laws of vector addition are called vector quantity. The physical quantities which have magnitude means geometrical length, which have magnitude as well as or you can write along with as well as a specified direction. A specified direction. You can also write fixed direction or certain direction. All are same. And obey laws of vector addition. Vector addition are called vector quantities. You can also write in place of laws of vector addition and obey law of parallelogram law of vector addition. You can also write obey triangle law of vector addition. You can also write obey law of polygon law of vector addition. So you can write in place of law of vector addition in the form of triangle law of vector addition, parallelogram law of vector addition, or polygon law of vector addition. All are same. In laws of vector addition, may be parallelogram law of vector addition, triangle law of vector addition, polygon law of vector addition. So I have written laws of vector addition. Okay, this is general term. This include all the laws such as parallelogram, laws of vector addition, triangle law of vector addition, or polygon law of vector addition. Okay. Vector quantities have mainly 3 points, which are, first one is magnitude. What is the meaning of magnitude? Magnitude is the geometrical length of vector. This means geometrical length. I will teach you about magnitude in detail. Here you can also define magnitude. What is magnitude? I will teach you in next class. magnitude means geometrical length. you you only remember magnitude means geometrical length. You only remember magnitude means geometrical length for solving question. As well as a specified direction. A specified means fixed. You can also write here certain direction or fixed direction. Specified means fixed. And last one is triangle law of vector addition or parallelogram law of vector addition, polygon law of vector addition or laws of vector addition. Okay. Vector has mainly 3 points: magnitude, a specified direction, and laws of vector addition. Magnitude means geometrical length. A specified direction means certain direction. Vector has certain direction. Which line has a specified direction? This or this? This now. This line has certain direction, but this line has not a fixed direction. Therefore, vector can be represented by a straight line, not by a curved line. Okay? This is wrong or this is correct. The length of this vector gives magnitude and arrow gives direction. Can you say about direction of this line? You cannot say. But when I put an arrow, then you can say this is going towards this. Okay? Therefore, arrow shows direction only. Arrow shows direction. So I can write arrow shows or indicates direction. Okay. Now I am going to represent a vector quantity by geometrical method or algebraic method. First of all, I am going to teach you algebraic representation of a vector quantity. Algebraic representation of a vector quantity. How can you represent a vector quantity in algebraic form? In algebra, you have already studied such as a plus b whole square, a plus b whole cube, etc. This means that in algebra there are a large number of letters. So algebraic representation means a vector quantity can be represented by a letter, alphabet letters, such as A, B, C, etc. We draw a line, a straight line, and the length of this line gives magnitude of vector. When we put an arrow, then the arrow shows direction. Therefore, I also put an arrow over this letter which shows a vector quantity. This letter only shows magnitude of vector, but an arrow is given over this letter, both will be make a vector. Both will make a vector quantity. C is the magnitude of vector and arrow is the direction. Both will make vector quantity. etc. You can write by using two letters also, such as AB, BC, and so on. But you can never write more than two letters, such as ABC. This does not represent a vector quantity. Why? Let us consider a line and I put an arrow on this line. This shows a vector quantity. Let we take this point as A and this point as B and this point as C. What will be the length of this vector? Can you say? Length of this vector ABC or AC? We cannot write ABC because length of a line can be denoted by a single letter or two letters, but you cannot represent length of a line from more than two letters. Therefore, this does not represent a vector, but this represents a vector quantity whose direction is from A to C. A is initial point and C is final point. This line shows that A is initial and C is final. Okay. Now I am going to give a question. Which of the following represent this shows option answer this shows answer will be one option or more than one option. Which of the following represent vector quantity? This represents vector quantity. This also represents vector quantity. This also represents vector quantity. But this does not represent vector quantity because there are three letters. Magnitude of a vector cannot be denoted by more than two letters. Magnitude means length. Here, tail is above B, initial point is above B, and head is above A. Therefore, direction of vector from tail to head, B to A. Okay? Next. Next, I am going to teach you about geometrical representation of a vector quantity. Geometrical representation of a vector quantity. How can you represent a vector geometrically? First of all, we draw a straight line because vector has a fixed direction or certain direction or a specified direction. And we put an arrow anywhere. This shows direction, and both will make a vector quantity. This figure shows that this is initial point and this is final point. So this point is called initial point, also called as a starting point. Also called as a starting point or tail. I am teaching slowly so that you can understand properly. This point is called final point, also called as terminal point or head. Not head point. Simply I can write head. This figure shows that the direction of vector quantity is directed from tail to head. So I can write any vector quantity is always directed. Any vector quantity is always directed any vector quantity is always directed from tail to head. Okay? Next, I am going to teach you how to represent a vector quantity by boldface letter. Any vector quantity can be denoted by bold-face letter. Bold-face letter means suppose this is a letter, this is bold letter, which shows vector quantity. A large number of letters. You can also write by using two letters, but both letters will be bold. Okay? You cannot write more than three letters, so I cannot write ABC. This is wrong, because I can only represent one letter. I can only represent by one letter or two letters. I cannot represent more than three letters. Okay? Now I am going, these bold letters also show vector quantity. In NCERT books, you see many letters which are bold. Those bold letters in NCERT books will represent vector quantities. Okay? Now I am going to give another representation of vector quantity, which are bar over a letter. Any vector quantity can be denoted by bar over a letter. Okay? Such as A is the magnitude of vector and bar shows direction. B is magnitude of vector, bar shows direction, etc. You can also write by using two letters, but you cannot write a vector by using more than two letters. So you cannot write ABC. This will be wrong representation. Okay? You can study vector in mathematics also. You can study vectors in mathematics also. In mathematics, in some mathematics books, vectors are represented by bar over a letter. So I have taught you about this representation. Okay? Got it? Now I am going to end the class today. I will discuss about magnitude, a specified direction, and laws of vector addition in detail the day after tomorrow. Have a nice day. Thank you.